All right, so this is a vocabulary review. Watch this review and then do the assignment. I will go over it with you and you'll have time to go over it in Kami. All right, so we have two choices here. Um, the tendency of an object with mass to resist the change in motion. So if we were to choose this is inertia. It's a property, right, that keeps objects either um, stopped or moving. So objects at rest want to stay at rest. Objects with constant velocity and direction want to have the same speed and direction. All right. The maximum speed that can be attained by a free-falling object due to the resistance of the atmosphere in it is falling through. So there's a force of drag here and weight. So we continue to fall, but we fall a lot less. The speed becomes less. There's no acceleration. We become a constant speed. So on the moon, because there is no air, the gravity on the moon can pull a hammer and a feather, and they'll both land at the same time. Now, of course, in Earth, it doesn't happen. So this is called terminal velocity. Terminal means to stop. So we stop the velocity at a certain speed. The state of being, an object being acted solely by the force of gravity. So this is called free fall. Right? Free fall, you feel weightless, um, and there's only one force acting on it. So remember, we have drag when we get to terminal velocity, but this is free fall. An object with greater mass and more inertia, it takes more force to change their motion. All right, so that's Newton's second law. I'm sorry. This one is, let me do this again. A law which states that an object at rest or in motion stays at rest or in motion unless acted on a balanced force. I was looking at this definition here. And of course, this is Newton's first law. Sorry, because we have inertia, which is the property of objects depending on their mass. So it's easier to move a beach ball than a bowling ball. The law that states that within an object at rest or motion stays at rest or motion unless that's a duplicate here. So the resistance that one surface or object encounters with when moving over another. So that is a friction. So because of the roughness depends on the weight and the surface roughness here. So and that's called friction. Right? If it wasn't for friction, we would not be moving, being able to walk, wouldn't be able to drive our car because we'd just be slipping around. A sketch used to show the magnitude and direction of a force. So we have some arrows here. We have a normal force, we have a frictional force going this direction, and we have a normal force, that's the support force, and then we have the application force. So that is a free body diagram, a sketch. So that's a free body, and the diagram is this drawing here. All right. The force of attraction between two objects of strength depends on the mass of an object and the distance. So here's the moon or an asteroid and some asteroids. The moon is pulling the smaller objects. So that's gravitational force. Gravity. Everything that has mass, even you, has gravity. The amount of or quantity of material contained in an object. So the more tightly it's packed and more of these atoms inside, it's called your mass. So this has less mass, and that's demonstrated by more spaces between the atoms, and here is more mass. The downward force, that's supposed to be the downward force of an object with mass due to acceleration of gravity. So because of gravity, a mass is pulled down, and then we call that weight. So your weight varies from the distance from the ground, or so if you're in an elevator, you have more weight at the bottom than you do at the top because you're further away from the center of the earth. All right, so that's our definitions for this week. So what I'd like you to do is take some notes on this, and then submit the answers in the CAMI assignment.